Hey everybody, good morning. Mr. Schultz here. We're going to jump into the next set of notes. We're still focusing on basically different ways to collect different types of evidence. So we've been doing this now for a couple weeks, and this week we're going to focus on firearms and tool marks. So we'll jump right into it. Right. So we're on evidence collection 3. Firearms and tool marks. So we'll jump right into this. You can see the learning objectives. They are also on Canvas, and you can take a look at those at your leisure. So our assignment this week, we're getting ready to do our third quarter presentation. So you're going to choose an item of evidence and present a 3 to 5 minute discussion on the proper collection procedures for that particular piece of evidence. A list will be included on the assignment page of Canvas. This can be done live during office hours if you want to do it that way, or you can prepare a video, 3 to 5 minute video presentation, and you can send that or submit it through Canvas, and we can do that as well. We're not going to do it live during the live sessions because we would kind of fall a couple weeks behind, and I don't want to do that. So it'll either be during office hours. You can come in during one of the scheduled office hours and present, or you can do a video and submit that instead. All right, so let's jump into this. What are firearms? A firearm is a portable gun, a barreled ranged weapon that inflicts damage on targets by launching one or more projectiles driven by rapidly expanding high-pressure gas produced chemically by exothermic combustion of propellant within the ammunition cartridge. I think everybody, that's a pretty scientific term to describe what everybody knows a firearm is. And you have several different types. You have you're going to hear lots of terminology. Some of you might be familiar with this. Maybe some of you guys are aficionados or gun collectors, or you've fired guns before. Others may not be too familiar with it. So we'll try to keep the jargon down a little bit, but there's going to be, terms like semi-automatic and automatic and, handguns and, rifles, and just kind of knowing some of the basic terminology will help you out. So what are the parts of a firearm? Basically, you have a few basic components. You have the barrel, the firing chamber, and the stock in action. This is true of handguns, and handguns can be broken down into revolvers or pistols. You also have rifles. These have some of those same basic components, although it's usually considered a longer barrel. And then you have shotguns as well. Rifles and shotguns are very similar. The big difference between the two is rifles have rifling in the barrel, which usually fires a single projectile, and that helps that rifling, that grooves cut into the barrel, helps spin that projectile, kind of like throwing a football. Like when you throw a spiral on a football, it kind of helps with your accuracy. Same is true with the rifling on the barrel of a rifle. And then a shotgun has a smooth bore, and is going to shoot multiple projectiles known as shot. The barrel of a firearm is basically a long metal tube produced by drilling out a steel rod. The inside of the barrel may be smooth, like in shotguns, but more typically rifled, which is basically a series of spiraled ridges cut into the inner surface of the barrel. These ridges cause the projectile to spin as it travels down the barrel, enabling it to fly straighter and therefore improving accuracy. Those ridges also leave markings on the projectile itself, which can lead to maybe even in some cases individualizing a particular gun to a bullet, which is where a forensic scientist is kind of interested in. The firing chamber contains the cartridge when it is fired. The mechanism for firing, loading, and unloading is known as the action, and the rest of the gun is called the stock. So how is firearms collected? Now, firearm safety is a must at any crime scene. The good news is we won't be dealing with live firearms. Obviously, the school district would frown upon bringing any kind of firearm into the school. So any kind of firearm that we collect at our mock crime scenes would be, obviously fake firearms or pretty obvious mock firearms that couldn't be confused for a real one. Usually they're like a bright orange or something like that. And it's just simply for learning how to properly collect it and tie it into like a box or a container. So if it were a real firearm, if a firearm must be moved at a real crime scene, never move it by placing a pencil in the barrel or inside the trigger guard. Sometimes you see this in the movies. They'll take a pencil and they'll put it into the barrel of the gun and pick it up and make some profound statement on the screen. Well, if you do that and that gun goes off, you're going to have a lousy day, because when you put a pencil or a pen into the barrel of the gun, that barrel is going to be pointing directly at your hand, and it's a good way to lose your hand. Or if you're putting it into the trigger guard, you might make a very bad day for you and maybe somebody else at the crime scene, because if it misfires, it's going to shoot a projectile at whatever it happens to be pointing at. So not only is this unsafe, but it could also damage potential evidence that might be located in those areas. The gun can be picked up by a textured surface on the grips without fear of placing unnecessary fingerprints on the weapon. You'll be gloved up, obviously. Before picking up a gun, however, make sure that the gun barrel is not pointing at anyone. Again, don't ruin your and somebody else's day by doing that. Keep notes on the condition of the weapon as found and steps taken to render it safe as possible without damaging potential evidence. Firearms must be rendered safe before submission. So before you start packaging your firearm, you're going to make sure that there is no rounds in the chamber, that all the ammunition is removed. It depends on the type of gun. If it's a revolver or a pistol or a rifle, you're going to remove all ammunition. The firearm should be packaged in an envelope or cardboard box, and we have cardboard boxes, and I showed you those during the live session. So we would put it into the cardboard box, and we would keep the ammunition separate, right? And or the magazine or whatever, however it's loaded, depending on, again, the type of gun. The ammunition and our magazine should be placed in a paper envelope or bag. It's important that the ammunition found in the gun be submitted to the crime lab. We want to know the exact ammunition that was found. Any boxes of similar ammunition found in the suspect's possession should also be placed in the paper container and sent to the crime lab. So what's the different types of firearms? Now, again, we're going to try not to get into too much of the technical jargon of different guns and that stuff, but you should be aware of a few of these basic terms. So firearms can be classified into two groups: handguns and long guns. Long guns include rifles and shotguns. You also have semi and fully automatic weapons. In a semi-automatic weapon, a round is fired each time the shooter pulls the trigger. So you have to pull the trigger every time you want to fire. Now, as fast as you can pull that trigger and the actions are working properly, that's as fast as you can shoot a bullet or a projectile. In fully automatic weapons, it's a little bit different. The firearm will continue to fire as long as the trigger is depressed. So you can pull the trigger, hold it down, and it'll continue to firing until you run out of ammo. Okay. Now, obviously, automatic weapons are illegal. However, you got to remember, we're investigating crime scenes, so the people that are conducting these crimes or perpetrating these crimes aren't necessarily going to have legal firearms. A lot of times they're going to have illegal firearms, stolen firearms, or whatnot. In both cases, the action is controlled by the combustion of gases and the recoil of the weapon. What about shotguns and rifles? Well, a rifle, again, as I mentioned before, has rifling in the barrel, these grooves cut in the barrel, and the barrel diameter is somewhere between 0.17 and 0.5 inches. And it fires single projectiles, typically called bullets, right? A shotgun has no rifling and a larger bore and fires multiple projectiles. This is known as shot. And you have different size shot. You could have number 8 shot, you could have number 2 shot, you could have buckshot, you could have different types of shot. With revolvers and pistols, the revolver, and I'm going to get my little pointer here, the revolver has, and you can see it on this picture here, a cylinder that can hold several firing chambers, and it rotates sequentially to bring each chamber in line with the barrel. So every time you fire, one of these, the ammo inside the cylinder would rotate up to the firing chamber. Okay. And then in semi-automatic pistol, the forces generated by the burning gunpowder forces a slide backwards against the spring. So if you take a look, it's kind of hard, but I guess you can see it pretty good. This is the slide, right? So when it's fired, this kind of goes back, and then it reloads, right, the next cartridge from a spring-loaded magazine. And the magazine's usually in the grip of the weapon. So here's the magazine here. So it would basically take, once it's fired, and reload the next round into the firing chamber. So let's talk a little bit about the ammunition, because that's another thing you may end up collecting at a crime scene, is the ammunition, either fired or non-fired ammunition that might be there. The bullet is the projectile that is fired from the barrel of the firearm. However, when you look at the whole thing, you also have the cartridge case, which holds the propellant, primer, and the bullet. So if you take a look, you can kind of see in this picture, this back part here is the cartridge case, and you have the gunpowder in here, and then a primer. Most guns, not all, but most guns are center fire, some are rim fire, but you have this center area, and when a firing mechanism strikes this, it basically ignites the primer, which then ignites the gunpowder and pushes the projectile out of the cartridge case and down the barrel. The primer is a mixture of chemicals that are detonated on the impact of a firing pin, and in turn ignite the powder and charge that, and that's the charge that propels the bullet. Bullets are typically made out of lead with partial or total encasing in another metal, such as copper, aluminum, or steel. You'll hear some more technical jargon in here. You might hear things like, full metal jackets and that type of stuff, and they're kind of referring to the type of ammunition. So bullet styles include round nose, wad cutter, this is for target shooting, semi-wad cutter, full metal jacket, soft point, hollow point, semi-jacketed hollow points, and so on. Metal jacket bullets are typically used in semi-automatic weapons. The reason they're used in semi-automatic weapons is their harder surfaces are less likely to jam when feeding out of the magazine and into the firing chamber, as I described on the previous slide. A great deal of information can be supplied by the bullets at a crime scene, even when there's no weapon. So it's important to kind of collect all the bullets as well as any cartridge casings that might be found at the scene. So the bullets, as I mentioned before, will get these markings on the side. So if you take a look, you can see some of these markings on the sides of these bullets. That's from those grooves inside the rifling. And that's where it kind of becomes important. Sometimes this will give us some class characteristics that, could this bullet have come from this gun? And we can give a certain, idea of, yes, it has the same class characteristics based on the distance apart from the grooves or whatever. And every once in a while, you even get lucky and you can actually have some kind of strange anomaly on one of the bullets, and it might even be individualized to the specific gun. The same could be true with cartridge casings. I'm going to show you that on the next slide. But cartridge cases typically consist of brass or nickel-plated brass. There could be aluminum. Like shotgun shells even have plastic, right? So shotgun cartridge cases are made out of brass with some kind of plastic or paper. But we can also look at the back of these. And this is kind of the back of some of these. These are all 9mm, I believe. They're usually stamped with the manufacturer's information, and this is a class characteristic, so we can tell, what type of ammo they're using and who the manufacturer is. These are called the head stamp. And these class characteristics, as well as markings from the action of the weapon, can be valuable. Sometimes these markings, and you can see here on each of these, you see this indentation. That's where the firing pin was striking this particular ammo. And every once in a while, you might get something that could be an individual characteristics, again, on that firing pin mechanism, or even on the ejection portal can leave markings on the side of the cartridge case as well. That could be individualized, or at least give us an idea if it came from a particular weapon. Shotgun shells are kind of the same idea as the bullet, except instead of having one projectile, you're going to have shot, which is basically a bunch of little pellets. Shotgun pellets are usually lead spheres, although sometimes they can be steel or bismuth or tungsten. Pellets are surrounded by wadding and are classified by a number size. Basically, the larger the number, the smaller the pellet. So if you have number 9 shot, number 9 shot is going to be a smaller pellet than like a number 3 shot. Okay. They range in size from anywhere from 0.05 to 0.17 inches in diameter. Buckshot, which is even bigger, will be 0.24 to 0.36 inches in diameter. The wadding protects the shot from the hot gases produced by the burning gunpowder and keeps it together as it exits the barrel. The wadding consists of paper or felt or plastic, and it can be useful in helping to identify the manufacturer of the ammunition. If you don't have any cartridge case, sometimes that might be all you have to go on. Close range shootings with a shotgun may result in both traces of the wadding and the shot entering a wound, and that can be recovered. All right, so how do we collect these things? Most of the time, if bullets are fired, they're going to be embedded in something, either a person or some kind of surroundings like wood or plaster or something like that. So when we're dealing with bullets embedded in wood and plaster, don't attempt to dig them out, because again, remember those striations on the side are key pieces of evidence. And if you sit there and use a knife or a screwdriver or something to try to pry the bullet out of whatever happens to be embedded in, you're probably going to be leaving extra markings on the side, and you can ruin the evidence. So you remove it by cutting out a portion of the tile material in which the bullet is embedded in. So if it's embedded in a piece of wood, you would kind of cut around that, or if it's a piece of plaster, you would cut around the bullet and keep the plaster. Send the pieces of the material containing the bullet into the laboratory. Cartridge cases, usually you're not going to have to worry about digging them out. They're usually on the ground, right? So it may be possible to determine the position of the shooter by the location of the ejected cartridge casings. Make a sketch with accurate measurements of the location of the fired cartridge cases. Make sure when you photograph these that each one has their own evidence marker, but also when you take the pictures, make sure the photographic log and the sketch with the numbers and the measurements all kind of match up. Again, package each item separately and mark the packages with all the pertinent information. Removal of evidence from a body of a deceased person. This is going to be done by, usually medical professionals are going to do this. They usually x-ray the body first, but you'll probably want to tell the doctor to make sure that they use non-metal forceps. If they can, use either their fingers or rubber-tipped forceps instead. Bloody bullets can then be washed in running water without scrubbing and then sent into the lab. Usually you wrap them in soft tissue paper, seal them in a labeled paper envelope or box. Make sure you package each bullet separately. Again, if you package them in the same packaging, they're bumping against each other. They're going to add striations. Do not mark the bullet or allow it to be marked. Mark the sealed container with all the description and the pertinent information of the bullet and so on. Shot wads. When a shotgun's fired, the wads can travel along or behind the shot charge for a short distance. In those cases involving close shots, wadding may be found either in the victim's body or his clothing. Follow the same packaging procedures as you would for the bullet. The pellets, we're not quite as worried about the pellets as far as getting those out of whatever it happens to be embedded in a pristine manner. So you still want to try to do as little damage to them as you can, but remember, shotguns don't have the rifling, so usually you're not going to get any kind of markings on the pellets that would conclusively tell you which gun they may have come from. So for pellets embedded in wood, plastic, etc., handled in the same manner as the bullets embedded in solid objects. If it is not possible to submit the material in which the pellets are embedded, pellets can be dug out, but try to take care again not to mutilate them any more than absolutely necessary. If removal of the pellets from a body of a deceased person, again, you would use x-ray to help locate the pellets, and then the doctors would try to use special care recovering the pellets so that there's no undue damage to them. Rubber tip forceps would be recommended. Loaded shells or cartridges. There could be live rounds that haven't been fired. You're going to collect and submit them to the laboratory. All ammunition associated with the case should be sent in. It can be used for test firing and distance determinations. Exactly duplicating the ammunition used may be critical. right? Document where such ammunition was found. If the number of cartridges are relatively few, they can be handled the same manner as the fired bullets. If large quantities are there, then you should place them in a cardboard box or wooden container, label, seal, and deliver to the lab. We also have gunshot residue. This is pretty typical for handheld guns, revolvers, and pistols. You can get a little bit of gunshot residue from certain other long guns, but it's usually happens a little bit more consistently with handguns because you can see the close proximity, this big plume of smoke coming out of the gun. This is the residue they're referring to. It can get onto their hands or clothing, and we can detect that, right? It has a certain chemical trademark characteristic that we can actually test with other gunshot residue test kits and tell if it's there. This particulate is going to be made up mostly of lead and barium and antimony, the three elements found in the primer mixture of a bullet cartridge. This particulate will escape the gun from any available opening, and then in this vaporous plume, the plume you will then solidify into fine particles and settle on surrounding surfaces. This could also be important if it's a real close range. Sometimes you'll have powder burns and some gunshot powder or residue on the victim if they're close. So when we're talking about gunshot residue, you got to keep a few things in mind. Okay, timing and the time of the activity. As time passes, from moment the incident occurs, the subject containing the potential gunshot residue particles can have particle loss due to activity. So if it's been 4 weeks since the incident happened, obviously the person's probably not going to have too much gunshot residue still left on them. But if it happened within hours, then they may have some still there. Contamination. Officers collecting from subjects need to be especially cautious as they and their surroundings can contain gunshot residue. Therefore, wear gloves, be aware of potential contamination sources around the collection area. It's not uncommon to find only one or a few gunshot residue particles, and you don't want to be the possible source of these. So, if an officer was firing his gun recently at the gun range, he could actually transfer the gunshot residue particles from him to the possible suspect. Preservation of clothing. Clothing items should be packaged individually for analysis so no contamination occurs, and keep them separate. You don't want, again, if you package one person's shirt with another person's shirt, then there can be a transfer of the gunshot residue from one piece of clothing to another. Bagging of the subject's hands. If it happened recently and you have a suspect and you're pretty sure they may have been the shooter, then if you can't do a collection at the scene, a lot of times you'll have these portable kits and you can swab their hands right at the crime scene and see if you can detect some gunshot residue. But if not, then it's highly recommended that the subject's hands be bagged before being cuffed. They'll put basically these plastic bags over their hands to kind of trap the residue, gunshot residue inside. Occupation of the suspect could be important. It's important to note the occupation of the suspect. Some lines of work can have potential to deposit similar particles as to those discharged from the firearm. And then keep in mind the prior activity. It's important to note that prior activity of the subject. For example, if the subject had just been at a shooting range earlier in the day, then you would expect to find gunshot residue on his hands. Tool marks. Let's move into tool marks now. This will be a little bit shorter than firearms, but a tool mark is any impression, scratch, gouge, cut, abrasion made by a tool that is brought into contact with an item, a surface. It could be in wood, could be in another metal surface. It usually leaves an impression of the tool. In some cases, tool mark identification may link a person to a tool used in the commission of a crime. Sometimes they can even be individualized again. Usually when you have tool marks left at the scene and there's no tool, right, because usually the perpetrators will take the tools with them, just like normally they take the gun with them and leave maybe just shell casings or bullets behind. But what you can do is you use a casting kit. You usually have several different things. The ones I ordered for next year are going to come in a tube. I'll show you a picture of those on one of the next slides. We also have the kind that you mix up by hand and then you kind of apply it to the tool mark with a little tongue depressor. All right, so first you're going to photograph the impression before casting it. Just like you photograph a fingerprint before lifting it, you're going to photograph the impression before casting it. When making the cast, be prepared to act quickly and methodically. Once you usually have these two tubes, and once they're mixed together, you have a certain period of time, a matter of minutes, before it starts to harden. So you need to get it into the impression before that substance starts to harden. So time is often a critical factor in successfully making the cast. Always use clean gloves when handling the evidence. This is one of the ones we ordered for next year. Accutrans, you have the two different substances. Once these two tubes are mixed in this front tube and applied to the impression, usually within a few minutes, you have a hardened, almost like rubberized impression of the tool mark. Label the container just before collecting an object and seal the container immediately after collection. Clean out any loose material from the impression when possible without disrupting the impression. Never discard a cast, regardless of condition, even if it turned out really bad. Keep it when removed from the impression. And then be sure to save and submit all casts to the laboratory. And the reason you want to keep those bad ones even is because they could have some trace evidence embedded in there that you don't notice until it gets to the lab. Close the container, seal the entire opening with evidence tape, and then write your initials and identification number and date and all the pertinent information on the seal. Make sure the container is also labeled with the description of the item cast, appropriate identifying data, your initials, identification number, all that. And then the item with the tool mark is collected. It should be packaged separately from the suspect's tools. So if you have a tool that may have made the mark, obviously you would keep those separated from each other. This prevents any additional markings, impressions, or other damage. Never place the suspected tools into the impression. Usually what they do in the lab is they'll make another mark with the tool and then make another impression and compare those two. All right, so that kind of takes us through that. And this week is a little bit of a weird week because of ACT, but that's kind of in the past already. But I also am going to be on Thursday, which will be coming up tomorrow actually. I'll be going to one of our middle school, Feeder's Middle School's science classes to talk about our program, our forensic science program. So I may be like about 5 minutes short in some of our classes on Thursday, but that should only affect really 2 classes. All right, guys, so that's it. Hopefully you guys have a great week, and make sure you guys work on your presentations and get those either recorded or come to the live sessions, and you will be presenting them live. We'll probably start presentations next week. All right, have a good day.